Second half of section 6.3 here, example 4, multiplying binomial radical expressions. What is the product of each radical expression? Here we have a binomial, 4 plus 2 squared root of 2, times a binomial, 5 plus 4 squared root of 2. So we are going to FOIL. First times first, plus outsides, plus insides, plus lasts. In each individual term, we're going to simplify. 4 times 5 is 20. Here I can multiply my whole number parts times my radical part. Same idea here. 5 times 2 is 10, and I have my square root of 2 by itself. In my last terms, there's a little bit more here. I have whole number parts in 2 and 4. I can multiply those and get 8. Now, my square root of 2 times my square root of 2, since I have the same index, they're each 2's there, I can write this as one radical. Square root of 2 times 2. Here I'm looking for groups of 2. I have 1, so I can take out a 2. Or I could have multiplied them and had the square root of 4, which I also know is 2. So this is going to be 8, and since we're multiplying by our square roots here, it's going to be 8 times 2, which gives me 16. Now, I can combine my like terms. 20 plus 16 gives me 36. 16 plus 10, since these have the same radical parts, same indexes, same radicands, gives me 26 square roots of 2. And I can't combine it any further because they're not like radicals. So we're going to complete these just like if our radicals were x's, for example. Okay, we'd take x times x, x squared. We'd take our x's different than our coefficients. Same idea here with radicals. So again, a binomial times a binomial, so we are going to FOIL. Firsts, outsides, and we can't multiply them together because this isn't a square root and this is. They don't have the same index. Insides and lasts. Simplify each of them. 15, 3 square root of 7. Here I take minus 5 square root of 7. We put our whole number parts in the front, or integer parts there. And here I can write this as one radical. I'm looking for groups of 2, and I have a group, so that comes out as a 7. Or I can take the square root of 49, which also gives me 7. We're going to combine like terms here. 8 for my integer terms. Here for my radical terms, 3 minus 5 is negative 2. And I still have my square root of 7 there. That part didn't change. And I can do that because, again, these are the exact same radicals. Both 2 is our index, 7 is our radicands. And I can't combine them any further because they are not like radicals. Now, again, we're going to multiply here. Since we're taking a binomial times a binomial, we're going to go ahead and FOIL. It doesn't really matter what our binomials are. As long as we have a binomial times a binomial, we can use the FOIL method. So firsts, 3 times 2. Outsides, insides, and lasts. Ran out of room there, sorry. Simplify each term. So here, 3 times 2 is just 6. Here I can take my number parts times my radical part. Same idea, number parts times my radical part. Here my number parts times my radical part. And since these have the same index, I can rewrite them as 1. Okay, multiply my 5 times 5. There, I can either multiply these to get the square root of 25 and take that and get 5, or I can take a group of 5's out and have nothing left on the inside, so square root of 1 is 1. and get 40 here. Now, when I combine my like terms, 6 plus 40 gives me 46, and 12 plus 4 gives me 16 square roots of 5. And I can do that again because these radicals are exactly the same. I cannot combine it any further though, because I don't have the same radical parts, just like if that was an x. Okay, I couldn't combine 46 plus 16x. Same thing here with the radical part. Remember that conjugates are expressions that differ only in the sign of the second terms. The product of two real radicals will be a rational number. So, same firsts, same lasts, just opposites, because we have opposite signs in the middle. So here, multiplying these, I'm going to take my firsts, outsides, insides, and lasts. 5 times 5 is 25, plus 5 squared is 7, minus 5 squared is 7. Then we're going to put our number part first. Remember, the sign goes with the number. Minus square root of 7 times 7. Since they have the same index, I can write them as 1, and I can take out that group of 7s as just a 7. Now, when I combine like terms, 25 minus 7 is 18, and 5 minus 5 is 0. So all I have is 18, and that should always work when you multiply conjugates. We're always going to get just a real number, okay, rational number. So the outsides and the insides are going to be opposites. Those will cancel when you combine your like terms, and you'll add them up to 0. We won't have those radical parts anymore. And this is going to be very helpful in our next type of problems here. So again, we're going to multiply here. We have a binomial times a binomial, and these happen to be special binomials because our firsts and our lasts have a relationship. Firsts are the same, and our second parts of our binomials are opposites. One's positive and one's negative. So we call these conjugates. Firsts, outsides, insides, and lasts. And again, if we wanted to, we could reduce these radicals right away, but if we wait till they're combined, that's going to take up a little bit less time because it's going to make it easier here to combine them because I have a set of 12s and I can take that 12 out rather than having 2 square roots of 3 times 2 square roots of 3. Okay, which is what we would have gotten if we'd have reduced to 12. Same thing here with our like terms. 6 and minus 6 square roots of 12 are 0. So whether we reduced those or not, it didn't really matter. So all I have left is 36 minus 12, which gets me to 24. Okay, so we can reduce this one, to simplify that to 36. 6 squared of 12. Here, put the number part first, minus 6. And then here we can write those as one radical because our indexes are the same. Set of 12s come out. We need a group of 2. They come out as a 12. And then 36 minus 12, because we got 0 there, gives me the 24. Same idea here with B. Firsts, outsides, insides, and lasts. Okay, simplify each one. 3 times 3 is 9. Here I get negative 3 square root of 8, and you can reduce that square root of 8 if you want to, but we don't have to here until the final step. Plus, again, my number part first, 3 square root of 8. Just like how we put x times 3 is 3x, same idea here with our radicals. Here, because the negative here, it's going to be negative. And since they're both square roots, I can rewrite them as 1. 8 times 8. Looking for groups of 2, so I can take that 8 out. Now, it looks like these are conjugates, which means that our insides and our outsides should cancel. Let's double check that. Negative 3 plus 3 is 0. Perfect. So all I have left is 9 minus 8, which is just 1. So we multiplied our conjugates and got a real number. And that's very helpful here because sometimes when we try and rationalize these, we're going to have a binomial in the denominator, and it's not going to be just finding a complete set here. So we're going to have to multiply by our conjugates to get real numbers in our denominator, because we never want to have radicals in our denominators or denominators in our radicals. So when a denominator is a sum or difference of radicals, we can rationalize it by multiplying both the bottom and the top, numerator and denominator, by the conjugate of the denominator. And we're multiplying by the conjugate of the denominator because that's the part we want to change. So to write this expression with a rationalized denominator, we're going to multiply by its complex conjugate, the denominator's complex conjugate, again, because we need to change the denominator, and using the conjugate there is going to give us a real number. So we keep our square root of 5, keep our square root of 2, we just change that sign in the middle. And whatever I do to the denominator, I also have to do to the numerator. Now, we are going to multiply. I'm going to do that by distributing in the top and foiling in the bottom. So in my numerator, I'm going to have 3 square root of 2 times square root of 5. And then I'm going to have 3 square root of 2 times the square root of 2. I'm going to simplify here. I can write square root of 2 and 5 under the same radical and get 3 square roots of 10. Because they have the same index, I can do that. Same idea here. Because they're both the same root, square roots, I can write it as 2 times 2. A set of 2 comes out, and I have 3 times 2. So I have 3 square roots of 10 plus 6 in my numerator. In my denominator, I'm going to have to FOIL binomial times a binomial. First times first, outside times outside, inside times inside, and last times last. Now, to reduce my radicals here, since they're the same index, I can take 5 times 5. Since they're the same index, I can take 5 times 2. Since they're the same index, I can take 2 times 5. And since they're the same index, I can take 2 times 2. I have a group of 5s, so that's just 5. Here I can't take a group out, so I have the square root of 10. Can't take a group out, so it's the square root of 10. Here I have a group of 2's, so I can take that out. To combine like terms, 5 minus 2 is 3, and square root of 10 minus square root of 10 is 0. So 3 is my denominator. Now I need to put my fraction back together here. I have 3 square root of 10 plus 6 in my numerator over 3 in my denominator. I'm going to go ahead and reduce. I can take a 3 out of 3, a 3 out of 6, and a 3 out of 3. Remember, if we take it out of one part, we have to take it out of the entire expression. So I have the square root of 10 plus 2, or 2 plus the square root of 10. It doesn't matter. And that's over 1, but dividing by 1 just gives us the value itself. So you can write these as 2 separate pieces if that's easier. Do your numerator and your denominator and then put them back together. If it's easier to keep your work together that way, that's totally fine. Just make sure you put them back together and reduce. I'm going to cut this here and do the last couple problems on another video.